Hello, today we're going to talk about trigonometric equations and how to solve them. We are going to use regular algebraic processes and procedures, but in trigonometric equations we need to link the value of a trigonometric ratio with the specific angle. Let's see with an example what that means. Here we have to solve each equation for theta that is between 0 and 4 pi, and we know that the sine of theta equals 1/2. So what we want to do here, we want to make sure that we want to find what theta is, knowing that the sine is 1/2. Note that the domain in this case is bigger than we usually do. So try this function and the other two. Pause the video and we'll be back in a second. So if we know that the sine is 1/2, in the unit circle, this will be 1, this will be 1/2, and the angles corresponding to 1/2 are the angle pi over 6 and 5 pi over 6. So these are the two angles in the first rotation, and I wrote them here, pi over 6 and 5 pi over 6. But we have to consider two rotations, so all the way to 4 pi. So I have to add another 2 pi here, and I will get to 13 pi over 6, and one here, and I will get to 17 pi over 6. So four angles within this domain have a sine that is equal to 1/2. The cosine is represented on the x-axis, so you can go ahead and try those. And then we'll talk about the tangent later. Pause the video and go ahead. So these are the answers. We'll come back to the warm-up in a bit, and we'll see how I found these values. Now let's look at an example of a basic trigonometric equation. Here I have that 2 times the sine of x is equal 1. So what I need to do, I need to consider the sine of x as my variable. And I can say that if I divide both sides by 2, I have that the sine of x equals 1/2. So up to this point, it is a normal algebraic equation. Now I have to go back to my knowledge in trigonometry to determine how much is, what angle x has a sine equal 1/2. And we have seen in the previous warm-up at the beginning that the angle pi over 6 and the angle 5 pi over 6 both have a sine of 1/2 in the first revolution. However, there is an infinite number of values that have the same, an infinite number of angles that have 1/2 as their sine. So I have to consider pi over 6 and all its coterminal angles. When I say coterminal, I mean pi over 6 plus or minus as many revolutions. So I can say plus 2 pi, plus 4 pi, plus 6 pi. So I represent it as 2k pi. Sorry, not very well written. 2k pi, meaning as many 2 pi's as I want. Likewise, this one also has to be written as 5 pi over 6 plus all the coterminal angles that have the same sign, so plus 2k pi. Notice that k may be negative, so I'm talking about any revolution counterclockwise or clockwise. And here on your notes you have a formal representation of what this solution is. I wrote 2k pi. The textbook says 2n pi. It doesn't matter as long as you understand that your k or your n represent a positive or a negative integer. So when we talk about a general solution in trigonometry, it means finding all the angles that satisfy my condition. So all the angles that have a certain sine or a certain cosine or a certain tangent. The easiest way to do it, of course, is to find the answer in the first revolution and then add 2k pi or 2n pi or 2 pi n. So we can say finding all the angles that have a certain trigonometric ratio. Now, practice 1 has a similar situation. Go back and, Pause the video and try this practice. And we see that the angles in the first revolution that have a cosine of root 2 over 2 are pi over 4 and 7 pi over 4. This is where knowing these values, knowing that which angle has this cosine or that sine or the tangent, comes extremely useful. Actually, it will be necessary next year. So what I have is that my angle theta could be pi over 4 or any of its coterminal angles. So it could be pi over 4 plus or minus 2k pi. And can also be, the angle theta can also be 7 pi over 4 plus or minus as many revolutions as I want. So plus 2k pi, where k again is positive or negative. Now let's look at another example. A little more complicated, because this time I have two cosine of x, one here and one here. Now the important thing is to consider this as your variable. So the cosine of x is a number that we're trying to find. And we should not play with the x, but consider cosine of x as a unity, something that has to be dealt with in one go. As if it were, for example, a plus root 2 equals negative a, where a is my cosine of x. So what I want to do here is treat cosine of x as my variable, and I will write that cosine of x plus root 2 plus cosine of x equals 0. And I continue solving algebraically, and I find that 2 cosine of x, the parentheses are always a good idea, equals negative root 2. And if I divide both sides, I have that cosine of x is equal negative root 2 over 2. At this point, I get a cosine that I know and I recognize, and I can figure out what angle has that cosine. Now, negative root 2 over 2 is about here, and the angles corresponding to this are this angle here and this angle here. So we're talking about 3 pi over 4 and 5 pi over 4. So my solution will be x equals 3 pi over 4 plus 2k pi, or 2 pi n, and x equals 5 pi over 4 plus 2k pi. Try the next one. Try the next practice, and let's see what we can do here. And here you have the answers. This is the solution in the first revolution, and this is the general solution. In example 3, the cosine is squared, so I have to solve it as a quadratic. I'll write it here just to make sure that we understand. It's like saying 2a squared minus 1 equals 0. And I have to solve it the same way. So cosine of x is the value that is squared, whatever the cosine of x is. So solving algebraically, I have 2 cosine of x squared minus 1, equals positive 1. I divide both sides, and I have cosine squared of x equals 1 over 2. And finally, I take square root of both sides, and I have that the cosine of x, cosine of x equals the square root of 1 over 2. Pay attention here. When I take the square root, I have to take both the positive and the negative square root. So that means that I have cosine of x equals plus or minus square root of 1 is 1, square root of 2 is root 2. I need to rationalize. So I multiply by root 2 over 2, and I have plus or minus root 2 over 2. On the unit circle, my cosine equals plus or minus root 2 over 2 will be somewhere here and somewhere here, meaning that it's giving me this angle, this angle, this angle, and this angle. So I have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, if I want to write the solution, I can write this plus a revolution, any revolution, this plus any revolution, and so on and so forth. But you notice that the distance between each of these is simply a quarter pi. Half pi. So what I want to do, I can write it in general term as that the angle x will be equal pi over 4 plus or minus as many pi half as I want. So k pi half. And that means the first one adding a pi half angle each time. So a 90-degree angle each time. You have something very similar in practice 3. Pay attention. Now we have a cosecant. If you don't remember what is a cosecant, what values each cosecant has, remember that the cosecant is the reciprocal of the sine. Pause it and see what you can do. Okay, you should have come up with 4 solutions in the first revolution. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. I can write each of them adding or subtracting full revolutions, but I notice that they are 2 by 2 at a distance of pi, or if you want, 180 degrees. So I can write that x equals pi over 3 plus k pi, meaning half a revolution as many times as I want, and x equals 2 pi over 3 plus k pi. So also adding or subtracting as many half revolutions as I want. Now, let's talk about something different. Let's talk about tangent. Here we need to remember what are the values of a tangent. But first of all, tangent of x is what I'm trying to solve for. So I take minus 3 on the other side, and I have 3 tangent x equals root 3. Divide both sides by 3, and I have that the tangent of x equals root 3 over 3. We should remember what is this number. Here, I remember that there are 3 values. One is short, one is medium, and one is long. The short one, root 3 over 3, corresponds to an angle that is pi over 6, or the one on the opposite direction, 7 pi over 6. So I can say that in the first revolution, the answer will be pi over 6 and 7 pi over 6. If I want the general solution, I will have pi over 6 plus as many pi's as I want, so k pi. And now you try practice 4. We need 2 answers, one in the first revolution and one general. Go ahead. These are the 4 solutions in the first revolution, and these are the general solutions. And let's look at one last example. Here I have one binomial times another binomial equals 0. So we're dealing with a quadratic. So what I want to do, I want to solve the 2 equations separately. So I tee up, and I have that 2 cosine of x minus 1 equals 0, and cosine of x minus 3 equals 0. And I solve them separately, and I find that the cosine of x can be 1/2, or the cosine of x can be 3. Now, this is not possible, so I have no solution on this side, because the cosine is a number that has to be between -1 and +1. Cannot be 3. But this one, on the other hand, we know, so we can find the solution up for the left side. And we have that in the first revolution, the solution will be pi over 3 or 5 pi over 3, while the general solution will be pi over 3 plus 2k pi or 2 pi over 3 plus 2k pi. And now practice the last one. And here we find that the sign is 0. So remember, the sign is the vertical value. So it's 0 when the angle is 0 or when the angle is pi. And the cosine is +1 here, so angle 0, and -1 here, so angle pi. Meaning that in both cases, my solution in the first revolution will be 0 and pi. The general solution is the angle 0 plus as many half revolutions as I want. So x equals 0 plus k pi, or x equals k pi. I hope it was clear, and we'll practice a little more and we'll continue from there.